Hello students, how are you? I hope you are doing well. So welcome to IIG Academy, and today we are going to discuss about the rotational motion. We will study the rotational motion. Okay, so rotational motion is basically the study about the rigid body. Okay, so in motion of, actually we will say the motion of rigid body. We will study that what is rigid body and all, and before that we will study type of motions. Okay, so first, in translation motion we have studied, if a mass m is moving on a straight path, then this motion is known as the linear motion, right? Linear motion. So in this motion you can see the every point of this mass m, every mass of this mass m is moving with a constant velocity, and if it's accelerating, then constant acceleration will be there, constant displacement is there, because the whole body is covering a same distance, right? That's why speed and velocity and acceleration, everything will be same will be happen if a particle is moving like this. A mass m is here, this is mass m. If it's moving, then you can see that motion of this mass m will be like this, right? And still here you can see the motion of every point, every mass in this mass m will be same, right? So this is the normal motion. This is the this motion is known as the curvilinear motion, because it's in the line but the line is curved. So we will say this motion is, wait a minute, curvilinear. We will say it as curvilinear motion. Okay, so these two motions are the types of translation motion. Okay, what is the important point in this motion? The important point we already discussed, the velocity of every particle will be same. The velocity of every particle will be same. Particle will be same. Okay, so in linear motion, or you can say these are the types of translation motion. The both are the types of translation motion. Okay, so in translation motion a particle can move on a linear path, or you can say straight path. That path is known as the linear motion, and a particle can move on a curvilinear path. Okay, so that thing will be known as the curvilinear motion. Okay, now if a body is rotating, like here a hinge is there, okay, and a rod of mass m is given and length l is given, and this thing is rotating, then this motion is known as the circular motion or rotational motion. This motion is known as the circular motion or rotational motion. Circular motion or rotational motion. Okay, so what is the difference between translation motion and rotational motion? Actually, in translation motion, as I told you, that velocity of every particle will be same. But in this case, the velocity of every particle will be different. Okay, it will depend on the distance from axis. Okay, so if I will take a particle here and one another particle here, then how to calculate the velocity in circular motion? We know that if angular velocity omega is given, then it will depend, the velocity will depend on the radius. We have already studied in the circular motion. We studied before the rotational motion, right? So in that chapter we have already studied that if you want to find theta from displacement, we can find angular velocity from velocity, and we can find alpha, angular acceleration, from acceleration. To do that, what we will do, we will multiply by r from coming to theta, and we will divide by r from coming to s to theta, from going to theta. Okay, so we will divide by r. Same thing will be applied here as well. If you want to come from omega to velocity, then you need to multiply r to the omega, and if you want to go velocity to angular velocity, then what you need to do, divide it by radius. Okay, r stands for the radius, that if I want to calculate the velocity of this particle, then the distance of this particle from the axis, that is the r. Okay, same thing will apply here as well. If you want to calculate acceleration from the angular acceleration, then you need to multiply with r, and if you want to calculate angular acceleration by acceleration, then you need to divide acceleration by r to get the angular acceleration. Okay, so here if I will give you this radius is r1 and the another radius for this particle is r2, then you can find the velocity. The velocity will be, this is v1, it will be equal to omega into r1. Okay, and for this one it will be v2, that will be equal to omega into r2. Okay, so here you can see in circular motion or rotational motion, the angular velocity will be same, but the velocity will be different. And one more thing, observation, you can say that if it completes a rotation, then the distance covered by this point will be depend on the r1, and distance covered by this portion, this fraction mass, will be depend on the r2. It will be 2 pi r2, that is the circumference of the path. Okay, so here we can say that displacement and velocity for both mass fractions are different. Okay, so that's why this is the main difference between translation motion and circular motion. Okay, and now the another type will come. This is the second type, and third type is combined motion. What will happen in combined motion? In combined motion, rotational motion will be there plus translation motion will be there. Okay, so the best example of this combined motion is the wheel of a car or anything. So if a wheel is given, if car is moving, then it will definitely it will rotate with some angular velocity, and it will move ahead as well with some velocity. So this motion is known as the combined motion. Okay, now what we are doing the study of rigid body. So after this thing we need to know that what are the rigid body. That is compulsory, right? So write down this thing, and we will move to the next topic, that is rigid body. What are the rigid body? Rigid body means distance between any 2 points in the body will be constant. In a rigid body, distance between any 2 points will be constant. Okay, so if I will take a example like this is a body, then I will take one point A here and another point B here. Then if the distance between A and B is not changing, not only A and B, any 2 points is not changing, it's constant, then this body will be called as rigid body. Okay, so what are the examples of rigid body? Are human body is a rigid body or not? It's not, because the distance between any of 2 points, I will take these 2 points, my hands, right? So distance between my fingers is now higher and now is lower, so distance is changing. So human body is not a rigid body. Okay, so what are the rigid body example? You can take a anything made up of metal, okay, around you. You can see around yourself and you can see that what are the rigid body. Okay, so the first property of rigid body is, you can write, first property of rigid body is distance between any two particles, distance between any two particles must not change. Distance between any two particles, any, you can assume any of the particle, this anyone, okay, pick two, any of the two particles. If the distance between two particles is changing, then that body will not be a rigid body. So first condition is distance between any two particles must not change. Okay, now write down the second point. What are the second point? What is the second point? With respect to a point, another point will be in rest or in circular motion. Okay, so first distance will be constant. First is constant distance. Okay, what is the second point? With respect to another point or particle, another point, one point or particle will be in rest or in circular motion. Why in circular motion? Tell me why. Okay, so there is a simple reason. If we are saying that distance between A and B can't change, distance between A and B can't change, then if you will move this thing in rotation or in translation motion, what will happen? Max to max, this A can rotate around B. That's it. The distance between A and B can't change. So if distance between A and B is not changing, then it can be in rest or it can be in rotation motion only. Okay, any point you can bring, you can assume any point in the body and throw that body anywhere, so it will rotate and move as well, but the distance will not be changed, but the one point with the another point will move in a circular motion, right, in a circular motion. So this is the second point. Now third point is, if I will take 3 points instead of 2 points, if I will take 3 points, one another point I am taking here, this is 3 point C. Now the angle between 3 points, any of 3 point in the body, any of 3 point is theta, then this angle is not going to be changed whatever we are doing with this body. Okay, throw this body with angular speed, angular velocity and some velocity and all, whatever happens this body, but the angle between these 3 points will not be changed, because A is fixed, B is fixed and C is fixed as well. So even though if you are rotating this thing, the whole thing will rotate, so angle between these 3 points will not change, right. So this is the third point, right, angle between 3 points will always be same. That's why angle between 3 points will always be same. Angle between 3 points will always be same. Theta will be same always. Okay, so theta is same. Now if theta is same, then you can say, if I will talk about the A axis is going through B, right. So if A is rotating somewhat theta 1, then C will rotate theta 1 as well, because the angle between C and A will be constant. So if it's going up to here, this is have to be equal to this theta 2, have to be equal to theta 1 to make this angle theta, to maintain this angle theta, right. Wait a minute, let me use another color. Okay, so now here you can see, if this A is moving from here to here by an angle theta 1 and this C is moving with here to here with angle theta 2. Okay, then this theta 2 must be equal to theta 1 such that the angle still will be equal to theta. As I told you, this theta is constant, right? So this theta have to be equal to this angle as well. After rotating to some angle, that will be theta 1. Okay, now if the theta for both points are same, then if you will calculate the omega. What is omega? Omega is d theta by dt. So if every point is rotating with constant angle, with same angle, not constant angle, so if every point is rotating with same angle, then this omega will be same as well. So that's why angle between 3 points will always be same. That's why omega of every point will be same. Okay, clear? Any doubt in this thing? Okay, now we will move to the next topic. Okay, now next topic is moment of inertia. We will discuss about the moment of inertia. Moment of inertia. Okay, so before going to moment of inertia, I will ask you something. Then a body is given like this. This is a body. Okay, and this body is rotating. This body is rotating through this axis with a angular velocity omega. Angular velocity omega. So I will take some points. This is m1. Okay, this is m2. The small fraction of mass I am taking. This is m2 and this is m3. Right. This distance is r1. This distance is r2 and this distance is r3. It is given. Now if I will write the kinetic energy of this body, there are many more masses are there, but I have taken only 3 masses. Okay, I can't write the infinite number of masses there, because I have taken only a very small portion of mass. Okay, there will be infinite number of masses, so I can't take I can't calculate kinetic energy for every particle. Okay, so I will calculate for 3, but you will understand. Okay, so if I will write kinetic energy of this body, then kinetic energy will be equal to what? Half of m square, right? We know that half of mv square, so half of m, but here we know that this is not m v square, this is not v square, so we need to calculate the velocity. So if this is the v1 and velocity of this m2 is v2 and velocity of this m3 is v3. Okay, we assumed, we don't know the value of v1 still, so I will write it as v1 square plus half of m2 v2 square plus half of m3 v3 square plus and so on. Right. So now we can calculate the value of v1. How? We can calculate the value of v1. How we can calculate? As I just told you before this thing, that the relation between theta, displacement, angular velocity, and angular acceleration and acceleration. If you want to calculate a velocity out of angular velocity, then what you need to do? You need to multiply it by r. You need to multiply it by r. The r is the distance at which that particle is moving along the axis. Okay, so from the distance of this m1 from axis is r1, so v1 will be equal to what? Omega into r1, because omega is given already, and the omega of this body will be, this particle m will be what? Omega. Omega is constant for everyone, so v2 will be omega into r2. Same here, v3 will be omega into r3. Okay, v3 will be omega into r3. Okay, now put all these value in the equation, then you will get kinetic energy. This is the kinetic energy of rotational motion. Kinetic energy is equal to half of m1 omega square into r1 square plus half of m2 omega square into r2 square plus half of m3 omega square into r3 whole square, right? Okay, now and so on. There many more masses are there. So okay, now if you will take half omega square is common, half omega square is common, then you will find kinetic energy R is equal to half of m1 r1 square plus remaining what will be, we have taken half is common and omega is common, then remaining will be m1 and r1. Okay, so m2 r2 whole square plus m3 r3 whole square plus and so on, right? And remaining will be omega square. Now compare this thing, compare this rotational kinetic energy with the normal kinetic energy that we know, that kinetic energy is equal to half of mv square. Okay, then this v is replaced by omega, that is angular velocity, right? So this was the velocity in translation motion, this half is there. Now this m is mass, in translation motion m is replaced by this term, this whole term. Okay, so in rotational motion this term will known as the, this term will work as the mass. In translation motion what is the work of mass? Mass is the thing that says us that what is the mass signified. Okay, so it will signify that we need higher force to move higher mass and we will need lower force to move a lower mass. So same thing, this thing will show that if this thing is high, then we will need higher force to rotate that thing, if this thing is higher for a body. Okay, and if this thing is lower for a body, then we will need a lower force to rotate that body. Okay, so this thing is mass for a rotational body and we will give one name to this thing, that name is moment of inertia. We will give a specific name to this expression, that expression is moment of inertia, moment of inertia. So now I think you have understood that what is moment of inertia and why we will take moment of inertia as m r square plus m2 r2 square plus m3 r3 square and so on, inertia, because the moment of inertia is mass in a rotational motion. Okay, it will work as a mass in a rotational motion. So from here you can see that mi moment of inertia will be equal to, for any body will be equal to what, summation of, this is the m1 r1 square plus m2 r2 square plus m3 r3 square and so on. So I can say that summation of m I r I whole square. So this is the moment of inertia of any body, any rotating body. Okay, so write down. Okay, now there are some things, some what we will say, the physical quantities on which the moment of inertia will depend. Okay, so as we know that we have written that moment of inertia m I is equal to summation of m I r I whole square. So the moment of inertia is depending on mass, moments of inertia depends on the radius, or you can say the position of mass of which we are calculating the moment of inertia from the axis of along which the mass is rotating. Okay, so you can write, the first point is moment of inertia will depend on the distribution of mass, distribution of mass, like there are many more masses and the all masses are rotating around the axis, then what are the distribution, what are the distance of masses from the axis. Okay, so the moment of inertia will depend on that. Moment of inertia will depend on mass, the total mass of the body. It will depend on the total mass of the body. If a mass is higher, then the moment of inertia will be higher, and if mass is very far from the axis, then moment of inertia will be higher for that as well. Okay, so these are the some physical quantities on which moment of inertia will depend. Okay, write down quickly. Okay, now before moving to the next topic, we will write down a note. Write down distribution of mass. Distribution of mass. So there are three types of distribution. One is linear distribution. First one is linear distribution. Second one is aerial distribution, or you can say surface distribution. Surface distribution. And third one is volumetric distribution. Third one is volumetric distribution. Okay, so linear distribution means a mass is distribution in a line like this. This is the example of a road. In road, the total mass is distributed in a line, right? So that thing is known as the lambda. Okay, what is the meaning of lambda? Lambda is the mass of a unit length. Mass of a unit length. Lambda is mass of unit length. Mass of unit length. Okay, so mass of this road is given m and length is given l, then this lambda will be equal to what? M divided by l, and that's why the unit of this lambda will be kilogram per meter. Okay, so if a lambda of something is given and someone will ask that what is the total mass of 3 centimeter or 2 centimeter or something x centimeter, then multiply this x to the lambda, you will get your answer, because lambda is the mass of unit length. If he is asking about the total mass of something x centimeter, then just multiply x centimeter to the lambda. Okay, now coming to the surface distribution. In surface distribution, what will happen? Anything will be given, the surface is given like this. Okay, so the mass distributed in a plane. Mass distributed in a plane. So m is given, the total mass, and area is given, that is the area of this body. Okay, now this is the mass of unit area, and this is denoted as sigma. This is denoted as sigma. Then sigma will be equal to what? Sigma will be equal to mass divided by area, and unit of this thing is kilogram upon meter square. Kilogram upon meter square. Okay, so if someone will give you the sigma, someone will give you the surface distribution sigma and ask you that what is the mass of 20 meter square or 10 meter square and all, then what you will do? Just multiply this 10 with this sigma, right? You will get your answer. Okay, now coming to the volumetric distribution, this is represented as rho, and this thing is equal to the density of that material. This is just the density. Why it's equal to density? Because as here we are dividing it by area, we are dividing mass by area, then in this case what we will do? We will divide the volume by, we will divide the mass by volume, and mass by volume we already know that mass by volume is density. So density will be equal to mass by volume, and this thing is represented by rho. So this will be rho. Okay. Now what will be the unit? It will be kilogram upon meter cube. Understood? And same thing as I told you, if density is given and someone will tell you that this is the volume, then calculate the mass of this volume. Just multiply that given volume with the density, or you can say volumetric distribution rho. Okay, many times we are using that rho for the density of materials, you know that. Okay. So now moving to the some questions. I have a question. Normal question is given that a mass m1 is here and another mass m2 is here. Okay. Distance between m1 and m2 is given as L, and a axis going through the mid of m1 and m2. Then you need to calculate I along this axis. Do it quickly. You can pause the video and you can do by yourself. I am telling the answer. Okay. So what we will do, as we know that I is equal to summation of mi into ri whole square. R is the distance of that mass. Okay. Here we have only two masses. The whole mass have a fixed distance from the axis, right? So we can take the r for the whole mass, then we will write it as I is equal to m1, and distance of m1 from the axis is L by 2, because total distance is L, so it will be L by 2. So write down L by 2 whole square plus then m2, and m2 is its same distance, that is L by 2 square. You will get I is equal to m1 plus m2 into L by 2 whole square. Okay. Now tell me, if this m2 was at the place of this m1, both were at the same place, that m2 is here as well, then your answer will be this as well. Okay. So this is the property of moment of inertia. If you are moving your mass without changing the distance from the axis, then the moment of inertia will not change. So you can write down the point. If you are changing your mass, changing your mass around the axis, if you are moving the mass, not changing, write down, if you are moving the mass without changing distance from axis, then I will not be changed. Okay. So that's why you can move this m2 in the parallel axis anywhere you want, or in this circular paths anywhere you want, because the distance from this axis will be constant, right? This will be L by 2 at any point you are going. This is the circular path. Actually I have drawn the vertical circle in this horizontal plane, horizontal circle in vertical plane. That's why it seems that distance is not equal, but the distance is L only. Okay. And if you are moving this mass in this thing, then and when we are taking the distance will be perpendicular distance only, or you can say minimum distance from the axis. Okay. So these are the 2 points you can say. Okay. And after this we will discuss about the calculating the moment of inertia of a rod, that is the linear distribution of mass, and we will discuss about the calculate the moment of inertia of a ring, that is the linear distribution as well. We will discuss about the moment of inertia of a disc and all. Okay. But today's class we will end here only. So in next class we will discuss about the moment of inertia of continuous distribution of mass. Okay. So thank you and bye बच्चे.